Hello, welcome to the webinar Introduction and Requirements for OMiLAB. Today, our presenter will be Wilfried Oet. I'm Zbigniew Misiak, I'm your host today. And as I told, our presenter will be Wilfried. Here you can see Wilfried's contact details. Wilfried is responsible for OMiLAB as a member of the board of directors, and he's contributing to the DigiFoF in organizational, managerial, and research role. As in the previous sessions, all microphones are muted, so if you have any questions, please expand the GoToMeeting tab and also type your questions in the chat window. We'll be answering your questions at the very end of the presentations. And agenda for today is as follows. In a second, I'll switch screen and give the presenter right to Wilfried. He'll do introduction to OMiLAB. He'll tell about example instance, about infrastructure, the virtual lab, the physical lab, about the delivery package, and then he'll continue telling about the requirements for OMiLAB, for the physical and for the virtual. And then we'll have session of questions and answers. So if you have any questions during the session, please feel free to put them in the chat. And afterwards, at the very end of our presentation, we'll be answering them. So the whole presentation part should be about 25-30 minutes. And then we have a block of Q&A so that you can dig deeper and learn more if you have any more questions. And now, let me give floor to Wilfried, who will be doing very interesting presentations. I must say that today I have seen his introduction to this and it was really amazing. I think you will enjoy it.
Thank you very much, Zbigniew, for the introduction. So let me begin by sharing my screen. So we should have now the same entry point as we had the exit from Zbigniew. Thank you very much for the time and the opportunity to talk a little bit about OMiLAB and to show you what we have prepared with respect to the package of OMiLAB to be installed and to be used within the context of DigiFoF. So in the first step, I would like to show you how such an OMiLAB could look like. So I don't want to start off with explaining the requirements and details and things, but just to see how things will operate. A little bit of warning, I didn't prepare slides with too much text. If there's too much text on them, I will try to skip them. I would like to give you an impression and give you some images and videos to see what are the capabilities, what is the setup, and how that can be used. So what we see here on the screen now is the installation of the OMiLAB at the University of Vienna. You see here the setup is in the form of a hierarchy. I will explain that one later on, but we have different layers that represent the different abstraction levels within the OMiLAB infrastructure. So that's OMiLAB at University of Vienna in Währingerstraße. You see at the bottom the physical elements, in the middle the design elements and conceptual models, and on top of that one then abstraction layers that can be arbitrarily defined. When we look at that one, the same picture from a little bit more conceptual perspective, we distinguish with respect to the OMiLAB installation in two different parts. One part is the physical lab. This is what you have seen in the previous slides. So that is everything that is required on a physical level. So in order to have students and guests and interested parties and stakeholders visit and do actually on-site interactions. And we have the virtual lab on top. So the physical lab, what you see in the bottom here, is separated into three different spaces. Something for creative work, so for design thinking, something for evaluation, so how can we make the design and the new business idea and innovative developments feasible and test them. And we have an engineering space that covers everything that relates to developing the elements that are required for the middle part. The physical lab is exposed to the virtual lab in the sense that on top of that one we see that we have services, we have tools, we have projects, so that that there's no physical presence required, but we can use the spaces from the bottom remotely and can interact with those things directly through the internet and through internet technologies. The whole OMiLAB for factories of the future is then exposed as a container, in a sense, to the as a competence network and to the OMiLAB community. So in a sense, we can share the physical devices via the virtual lab with others and can involve people who are not physically present and run this kind of setup. The whole thing is an experimental environment, of course, so that's not a production space that allows you to create new products and services that are off the shelf available, but to experiment and to practice things with respect to design thinking, conceptual modeling, and the execution in cyber-physical systems. The virtual lab is exposed using a framework. It's the OLIVE framework that you see at the bottom. It's a piece of software that allows us to interact with the elements remotely. So it's a microservice framework where all the capabilities of a specific experiment are made available to the external world. So what you see here at the bottom are elements that are made available for execution. This can take different flavors, so it can be in a sense of a remote execution, so you can run specific experiments directly from your browser or directly from your mobile phone, but also that you can download software, use them, and contribute back to the community. So it's the remote interaction that is made available. Each of these elements that you see here at the bottom is a specific microservice that comes with functionality, with content, with training material, with instructions, and can be freely customized and extended. So the idea and assumption is that these blue boxes at the bottom will grow over time. We will deliver as part of the package, and we'll come to that one later, a first set of these blue boxes, and you're free, of course, to design your own microservices and add them to the framework within your own virtual lab infrastructure. This microservice can be shared, of course, and can be also deployed then into other OMiLABs all around the globe, and should result in a network of interaction in order to share also experience and material in an open way. The physical lab is a physical space, as I mentioned before, and it comes with different types of engineering services and development services on the different layers that we have seen before. So it comes with modeling methods, modeling tools, cyber-physical systems that can be used for experimentation, and design methods that can be applied and can be used. So the physical lab summarizes everything in a space within your organization in order to run the experiments accordingly. The experiments, of course, as I said before, an initial set is available and can be extended and further developed based on domain-specific needs and requirements that might exist. Coming back to the initial picture, so how does the physical lab structure itself? So we have different parts that we see here represented. So we have on the left, that's the design and creative space. Here we see that we have to involve different stakeholders from different backgrounds in order to develop an innovative and creative business idea. So how do we do that? We apply design thinking methods. We do workshops, seminars in order to run those kind of things. On the other hand, we have an engineering space. That's the proof of concept environment, where we see what is required in order to make this creative space work, and how can we test and evaluate that one. That comes in different abstraction levels, namely the modeling part. So how do we realize software for the conceptual modeling? How do we realize the hardware that is required to operate on a cyber-physical system level, and how does these two things then fit with each other? And this is called evaluation space. That's what you see here. So we have a layer on the business perspective, the business idea, the business model. We have the proof of concept part, where we see the cyber-physical system, the hardware devices, and the conceptual modeling layer here in the middle is responsible to take over the mitigation and integration tasks, so that we formalize knowledge from the design part, from the business layer, and we abstract capabilities from the proof of concept layer and merge these parts using different flavors of conceptual modeling. Our initial starting point here is that we start with something that is well known, namely processes, B-up, as an environment that is already there, but it can be flexibly replaced by anything that is needed in order to represent the domain in a conceptual model formalized way. Right, I think what is on this slide I said already, so we have just a zoom in on the different elements. We use design thinking on the top layer, we use conceptual modeling for the middle part, and we have cyber physical systems devices at the bottom, and that actually structures then the projects and software that is required in order to run those kind of things. So the expectation is that we can extend and can develop different types of projects and different software solution, tool solutions, using that OMiLab infrastructure to come to an innovative and new way of doing things. That's why these two boxes on the left and on the right are shown in a vertical manner, so they span across the different layers and allow for an possible integration of parts. How does the physical space look like? How does the evaluation space look like? This is a brief animation. I mentioned before, I don't want to talk about content and text on slides, but I would like to show you how we have built this space that you have seen on the previous picture. So we try to have a little bit of a floating atmosphere. Then we have different quadrants on top of that, and you see those now, I think, with the different colors. They can have different sizes and different dimensions. And each of these spaces represents one area, one domain, one idea, one business innovation, one stakeholder that might be required. On top of that one, we propose to have a transparent layer that is actually the abstraction that should be feasible then. So from the bottom to the top, we abstract the capabilities of the physical part. And on this infrastructure, we again have then different types of abstraction depending on what is required. What do I mean with this one? We can have formal technical, for example, a workflow that is on a lower level of abstraction, and we can have design thinking methods like scene to model that I will show you later, or arbitrary business modeling parts that are on a different abstraction than a formal process model or formal workflow. At the bottom, we see that we have different devices that can be exchanged and can be used for those parts. In the middle part, we have the modeling layer. So we see here an example of VAB using flowcharts. We see another example of design thinking. This is actually on a different abstraction, or it can also be infrastructure that is represented down there. And when we move further up, it gets further into abstraction, and we see then we can use different possibilities in there. One part would be a design thinking approach. So we have haptic modeling in there, or we use models, or you use mathematics, whatever is the requirement that can be in there. This, I believe this one repeats. No, it doesn't. So just to give you an impression how the idea from the bottom to the top is represented. So the physical requirement of building up these spaces and these quadrants and these tables has also a meaning. It means abstraction from the bottom to the top, and it means decomposition from the top to the bottom. So we try to get more formal the further we get down there. So what we try to show here is that we need to bridge somehow the idea between a high-level business idea, innovative idea, and the execution and the proof of concept realization at the bottom. Right, this is just to summarize this animation. And now I would like to walk you through a little bit so that you can also understand how that works. This is one example experiment that I would like to show to you. That's the scene to model environment that we will put into the package, and that allows you to actually design business models using a haptic modeling approach. And now it doesn't run. So it's a bit out of sync, but it doesn't really matter, that's okay. What we should see in a few moments, oops, sorry, my mistake, is that we can design on one hand the business idea using the scenes approach from SAP that's happening on the top video at the moment. So there is a set of about 400 different icons that can be used in order to describe how such a business idea should look like. So what we see here at the bottom, it is a new innovative idea how car sharing could work. So I guess you're aware of Car2Go or other vendors or providers of this service, and how this part can be used in order to design a new and novel idea where cars compete for the client rather than clients searching for a car. We can represent it in scenes, as you see here on the top picture. In the background, what do we have? What does the system see? And I would like to also put that forward so that we have also software here in place that's part of the package. There's a webcam monitoring the design of the group of people that does that on the top, and actually recognizes the different elements and objects. So this is shown down here. We have here QR code recognition, and we understand that there's different elements put into place that can be then transformed into a first design, a first iconic diagrammatic representation in the scene-to-model tool. So that's the input of this. I'm very sorry, there's construction, it seems, that starts again here. I hope you can still hear me. And this transformation is supported by our scene-to-model tool. So what we do here is we actually digitalize the business model. Why is that important? When you think about our design thinking approaches, they stop when the stakeholders leave the room. So there's the need to then formalize the knowledge that has been put forward in a manual way. So you need to take a picture, you need to describe things, you need to collect all the posters that have been put on a wall and move forward. What our tool provides you with is that these kind of models are created automatically. So we can get the input from the haptic design, and we can then use this information to further refine it and further detail it. So these are screenshots of the scene-to-model tool. That's part of the delivery package for the OMiLAB. The further decomposition would then be to formalize this knowledge. What you have seen here in the, sorry, I will just move back, in the scene-to-model views. These are images of that are iconic. So that means there's no formal representation yet. And when we formalize this one, we can follow different types of approaches. So what we see here is we can have a business model representation using E3 value or using whatever standard is required. We can use processes for simulation, processes for design. And we, of course, need also understand the infrastructure and the data structure that is required for the specific case. So we say here we design first the business idea, and then we model the case appropriately. When we move forward, then we would like to also validate whether these models and this idea is feasible and if it's operational. And what I would like to show you here now is a quick demonstration how this validation could be performed and evaluation can be performed. What you see here is two robotic devices, two cyber-physical devices, M-bots. So these are the tiny elements that we see here in the middle. And what these two elements have in common is that they are not programmed, but they are, let's say, operated or controlled by the conceptual models that you have seen before. So what these elements will do is, I need to press the button one more time, I think. Now it starts to run. What these elements do, they digest the models. What you see here now, they start to simulate following a simulation algorithm that has been designed as a BPMN model. They know the preferences of users based on the user preference model, and based on this one, they will start their interaction. So in a sense, the logic and the knowledge that is stored within the models is actually transformed and is put forward to the capabilities of these robotic devices. These devices, one of these M-bots is also part of the package, and it is actually built in a way that it can interact and can be controlled through the conceptual modeling layer. That means the capabilities of this device have been abstracted, and we call this IoT adapters, in order to interact and talk to this part. So what you see here in the bottom left now is a flowchart model that actually controls how the robot should behave and what it should do, based on, of course, the capabilities that have been put forward. Right. And I think this should demonstrate that the customer has been picked up and moved to the specific place. I don't want to go into detail on the scenario, but I just want to show you how that looks like. Right. Summarizing these things, so what do we require in order to make such a OMiLAB ready and usable is that we have different contributing elements for the package. So everything that you see here now, every box is actually part of the package that we would like to propose to you. So we have, at the start I mentioned, I think, quite a lot of things. So we have the physical elements. This is the most easy one to explain. So what are the elements that will be provided? That this is a Logitech camera, that's a camera stand in order to have this scene to model environment ready. We have a Dobot Magician. I didn't show a video of this one, but it's a an arm that can pick up things and put it on other places, and we have the MBot that is actually operational. So this is a delivery of pre-configured and pre-installed devices. Each of these physical objects comes with a Raspberry Pi attached, so that means we need to establish connectivity in order to have the virtual lab ready then. From a software point of view, this is all open source and open use software, so you can find this software when you look for that online. We have software that is used for the scenarios and for the domains that we have considered as samples, and this is one part is the scene to model tool that uses the Logitech camera. We have the PUB tool that can be connected to the Dobot and the MBot, and then we have the generic part, namely the common platform to realize these two tools. So that why is that interesting and important for us is that we would like to motivate you to also consider to develop your own modeling language. So you can use an arbitrary one. We will have our samples in a specific one, but in case you have specific requirements from the domain, then this can be used and can be installed as well. For interaction, we have two elements. That's the interaction with the virtual, to expose the virtual lab. That's the OLIVE microservice framework. And on the other hand, we have the interaction in between the software components. That's for the IoT adapters. They are installed on the physical devices in order to make them run. Front ends is the other user interface element. So we have micro front ends for the microservices so that you can also see something. It's not only a web service, but you can also use those parts. And on the other hand, we have something that we would like to add to this one. That's an OMI-TV. Why is that interesting? That takes the analogy of a TV, of a CNN or BBC news channel, where the different OMiLABs can share their experience and share results in a common way, so that we can broadcast also to interesting stakeholders outside of the network what is going on and how is that happening. So that's a stream of information that can be continuously updated and added, of course, based on your own requirements. On the other hand, of course, a full package of documentation, installation support, and training material to make that happen. That is in close collaboration, in close interaction with the samples or example cases or example experiments that we would bring along in order not to start from scratch, so that you don't have an empty room and some devices and some tables, but you have already examples that are useful and can be demonstrated right out of the box. So that the assumption is you open the delivery package, you put those pieces into the prepared room, and at the end of the day, you can already show something. Right. I think I mentioned most of those things already. So we have documents that are part of the package. That relates to the infrastructure on one hand, to the software. So that's download and installation instruction on the software level. And of course, there's the cyber physical system devices that are described and also explained what is going on. So there's no hidden information or anything. Everything that we prepare for you is also documented. It can be reassessed afterwards. I think I mentioned already training cases and experiments in order to have to not start from scratch, but to have something ready. So we will provide the PDF file, for example, for all scenes, and including the QR tag, so you can start right away to build the scenarios that you would like to see. There's a second element, of course, on this one that relates to what are preconditions in order to make that work, to make the physical lab work. So that mainly has aspects with respect to space, and on the other hand, to networking and to hardware and software infrastructure that is required in order to make that parts work. There's a document describing this one that should guide you through the process of setting things up. Software, access to the software is provided in an open way. So the OMiLAB MPO that I represent will not develop software, but we will reuse openly available software that is actually downloadable and can be installed out of the box. For the starter package, I mentioned that one. We have the MBot, the Dobot Magician, the camera package, and that allows also for extension, and can also further elements could be commissioned in case that is required. But I think for the starter package, this is sufficient. Training samples. just to have these different abstraction layers ready. So we have training examples for different, how should I say, crossing different layers, namely from the conceptual to the physical layer. That would mean how do we control a physical device using a conceptual model, from the application layer to the conceptual level, namely how do we derive from a scenes design a process model, and then also the full cycle so that we get from the idea to the evaluation on the cyber-physical elements level. Good, that takes me to the last part of the presentation. I promise to be quick. That is, I think, quite a few of, there's some requirements that are needed for that one. For the space, we would recommend to have a rectangular shape. There's some requirements on space in order to have enough room available for the different elements to be installed and to be put forward. Things can be split, things can have a different layout, so that is all very flexible. That's recommendations that we would like to put forward. When it comes to hardware requirements, we recommend that we virtualize things, so that this is a modern infrastructure, and that means that we would propose to have a physical server that can run multiple virtual servers, so to separate also experiments, and there's a deployment mechanism and also a containerizing mechanism. We will provide Docker images in order to run then server applications appropriately, so without any dependency considerations and failing resolution stuff. So the recommended hardware is listed here below. I will not talk about gigabytes and bit rates, but this is the recommendation that we will put forward. It can be you can get a new one, you can reuse infrastructure, of course, since everything is virtualized and can be installed appropriately. This is just a quick look on an example. So this is the recommended server, a quick picture of this one, so that this one rack piece that actually holds here in the lab everything that we operate and that we run. From a network point of view, internet is of course required in order to have the virtual lab running, and this is I think a typical network setup that is a standard way of doing things. Just to give you a little bit of representation how we think that these elements work. The core consideration is to make these raspberries and network devices, cyber-physical devices, available via the internet. So we need to have access to them, and we need to have somehow a way to forward and to define configuration rules in order to access these devices then also from abroad in case the virtual lab is required. From a user's point of view, our recommendation is to have a development and experimentation setup for each layer available. That means we have on the physical layer, we have a computer, a development PC that allows for the interaction with the physical devices. On the conceptual modeling part, the second level, and on the design part, a third PC that allows then for sharing and also for demonstration, that provides a nice setup in order to run then appropriate scenarios. Right, for the OMiLAB TV, we need a smart TV, and that should be HTML5 compatible. That was a very quick walk through the current packaging of the OMiLAB for DigiFoF. I hope it was interesting for you, and I would now hand back to Zbigniew to handle the Q&A session. Thank you very much for your attention.
Thank you very much for a great presentation, Wilfried. I see one question, so we can rest on the slide that you have here. And Adrian asked, in the future, we intend to extend the OMiLAB from ULBS with new MBOTs, others than that provided by OMiLAB, a non-profit. Where will be the difficulty to connect this new hardware with the modeling tools and the software infrastructure? Could you detail a little bit, taking into account that in Vienna you have not only one MBOT, but many? So if you could tell a little bit more about the MBOTs, it would be, I think, interesting for all of us.
Of course. So the quick answer is this is not a problem. So the quick answer also includes, of course, that there's effort related to that one. That means what we do in order to make different MBOTs, different types of MBOTs, different robotic arms, or whatever is the cyber-physical device available, is an abstraction challenge. That means we need to expose the capability of such a device in a using web service technology. This is what we do through IoT adapters. They have been developed in, now I'm lying to you, but I think that's a Java infrastructure that is running on the Raspberry, and this is of course open source and can be extended. So what is the actual challenge is that you have to see the MBOT, or MBOT under quotes now, whatever the device is, and identify which capabilities are possible there. Just to give you an example, if you look at the MBOT that we see down here, if you think about what are the capabilities that this element can do, it is movement. So it has two wheels, it can actually move forward and backward. So that's two operations that you would need to realize. It can turn. Turn means one wheel back, the other wheel front, and then you turn left or the other way around. So it's like two more, so left and right. And then you have actually capabilities to measure things. So there's sensors installed. There's an ultrasonic sensor here in the front that measures the distance. You have the sensor in the bottom that measures color in front of it, and that needs to be combined with the movement elements, so that it adds these parts. In addition, this Arduino element here on top has sensors for light, for noise, for I'm not 100% sure, but there's 10 different sensors installed there. And what we try to do is with these IoT adapters to expose these capabilities accordingly to the conceptual layer using web service technology. Web service can be REST or SOAP. We are happy with REST services when we develop our tools, but the RDX6-based tools are capable to speak web service language. That means I can talk to the MBOT or to the ARM or to whatever device it is using a REST interaction. So in the next step, when we have identified the capabilities, we have implemented these web services, we typically try to understand what are the patterns. So what kind of patterns do we have when we would like to use these elements? So in the scenarios that we will provide, you will see that we have different movement patterns. For example, for the arm. The arm over there has movement from left to right to a certain angle, to a certain degree, but it needs to move through the center point, and that's a specific movement pattern that we have implemented already on the conceptual level, but on using technical flows and workflows. On top of that one, the sky is the limit. So we can have any kind of abstraction using then this REST interaction. So it's doable, it's easy doable as well, but that requires some programming knowledge in order to realize then these capabilities appropriately. Okay, thanks, Adrian.
Thank you very much. If you have any more questions, just type them in the chat. I don't see any more questions, so thank you very much, Wilfried, for a very, very interesting presentation. And as you know, this session was recorded, so it will be available later on for all of us. And have a good day, and see you again on the next DigiFoF webinar. Bye-bye.